Hey guys, so next we're gonna learn the binomial theorem trick, okay? So this is really useful when it comes to expanding, multiplying polynomials to the nth power. So in this case, as you can see, I have an example here that's to the fourth power. Like second, third, okay, let's do it. But actually, when it gets to the fourth and above, it gets really tricky. So I'm going to, I wouldn't say really tricky. I think there's more room for mistakes and it takes longer. So I'm going to show you a new trick with the binomial theorem, okay? So what I want you to think about right now is, as of right now, before the binomial theorem, what is the way you would solve this problem? Sorry, the bell is ringing. So 2x minus 3 to the fourth. The way we've been multiplying, or at least me, is I've been doing the box method, right? So think about how many times you would have to do the box. I actually challenge you right now to pause this video and to do it out by hand. Now, I'm not going to do it out by hand while I'm recording because it just takes a little longer and stuff. So I'm going to show you what I did. So to do it by box method, the first thing I would do is take 2x minus 3 times 2x minus 3. And then I would get a result, right? I get 4x squared minus 12x plus 9. That is 2x minus 3 squared. So I have to multiply again to get it to the fourth power, right? There we go. And then I get a result. Well, that is actually only to the third power there, and I still need to get to the fourth power. So I take that result, which is 8x cubed minus 36x squared plus 54x minus 27, and multiply it one more time. Okay, I guess in a way I could have done this trinomial times itself, and that would have given me the fourth power, right? But as you can see, it's a lot of time, a lot of spaces for mistakes, right? With the negatives and your exponents and things like that. So I'm going to show you a trick today of what we can do. What we're going to do is we're doing the binomial theorem, but we're going to use Pascal's triangle. So this is a triangle setup. It's called Pascal's triangle. Can you take a moment right now and see if you can see a pattern that's going on? I'm guessing the first pattern you said, oh, I know that the next row is going to start with 1, right? Well, what would be the next value inside? Some of you might recognize, well, 2, 3, 4, 5. So, oh, this must be 6. Same thing out here, 2, 3, 4, 5. So that must be 6. But then we get to this 1 to 3 to 6 to 10, and you're like, I don't know. Well, I'm going to show you something here. On the inside here, if I put these two and add them together, I get the next number there. That makes sense? Okay, so if we did that pattern, 5 and 10 is 15. 10 and 10 is 20. 10 and 5 is 15. And that makes sense what the 6 is, because 5 and 1 is 6. So the other thing to keep in mind is, how is this going to help us, right? Well, these actually help us with what exponent it is, okay? And I'm going to use n as the exponent, like the nth to the nth term or whatever like that. So right here, this first row is actually when n equals 0. The second row here is where n equals 1, 2, 3, n is 4, n is 5, and we just made the 6th row. And we could just keep going and going if we want to. Okay, so this Pascal triangle helps us with what coefficient we're using when multiplying the exponents of our term. I know that sounds really weird at first. So what we're going to do, I'm not going to worry about creating the next 3 rows. I think you get the pattern. If you want to try the next one, it gets bigger and bigger and bigger, right? But this is how we use our binomial theorem to expand. Okay, the first thing you're going to do is identify what row you are going to use in Pascal's triangle. This is all determined by what n equals. In other words, the exponent, right? You're then going to identify your A and your B term, right? Your A and your B. Now we're going to make sure that that sign goes with the B, okay? If it's minus, it needs to be a negative B, okay? Now what we're going to do is we're going to have the row of Pascal's triangle, and then we have our A term and our B term, and they're going to be just some exponent. And what we do is our A term will start with our highest exponent, the n exponent, and go down each time to 0. Where our B term is going to start with the 0 exponent and go up to n. Okay, so let's actually do an example. I think I have 2 examples for us to look at. All right, so we actually are going to be doing the example we did at the beginning where I had to do it the long way. So let's see how this works. So the first thing I want to point out is that we are doing where the exponent is 4. So in your Pascal's triangle, go back on the other page and look where n equals 4. Where n equals 4, we have the coefficients of 1, 4, 6, 4, and 1. Okay. Now, remember, we've got to look at our A term. Our A term is 2x, and our B term is negative 3. Remember, use that subtraction with the B value, okay? All right, so what do we do? First, we need to start, we have the coefficient of 1, right, from Pascal's triangle. Then we have our A term. And remember, I said a little while ago, you're going to start with the highest exponent, which is 4. And then we have our B term. And we have our lowest exponent of 0. That will allow us to get the first term of the expanded version. Okay. The next one, we have this coefficient of 4. We have our A term. Now as we go to the right, we're going to go down on the exponents for A. So this one's going to be to the 3rd. We have negative 3 for the B, and the B terms are going to go up. So instead of 0, it's going to be 1. What do you notice so far? The exponents add up to 4. 4 specifically, because that's what our exponent was going to, right? Okay, here's our coefficient of 6. We have our A term. Before it was 3, so now it's 2, because it's going down. Then we have our negative 3 for our B term, and our B term should be going up, so that is also 2. All right, let's keep going. So we have 4 here, so we have 2x. Now this one's going to be to the 1st because it's going down, right? And negative 3, we're going to go up, so that's to the 3rd, plus. And our last one, we have to the 2x to the 0, and negative 3 to the 4th. Now we're going to simplify it. One thing you want to keep in mind is that anything to the 0 is always what value? The value of 1, right? And anytime you multiply times 1, it's itself. So right here, what you want to do with your calculator is only focus on the coefficient stuff. So this is going to be 1 times 2 to the 4th. Now, I'm going to show you in a little bit why you always want the parentheses around the number and the exponent on the outside. I'm going to show you in a minute. And then of course, remember anything to the 0 is 1. And that is going to be our first term. So 16 is the coefficient for our first term here. And then we have a variable x, and that is to the 4th. Okay. Now, I'm not going to put an addition sign down yet, and this is why. Because here we have a negative to the first. We know negatives to an odd exponent is going to be negative. So in our calculator, if you need to, we're going to go 4 times. Now remember, I'm going to go 2 parentheses to the 3rd, and then -3 to the 1st. We get -96. So I'm going to put -96, and our variable is x cubed, right? X cubed. All right, again, next one, we have 6. Let's see, make sure you guys can see that. 2 squared times -3 squared. Okay, this is where I'm going to show you why you want to be careful with those parentheses. Okay, so our answer is a positive 216, and we would have x squared. Now I'm going to show you why those parentheses are very important. If I said 6 times 2 times -3 squared, oh, I forgot to do the squared there. Let's go squared, and then, or I guess, there we go. That makes me feel better. So see how I have the exponents on the inside right now? Watch this. It's negative, and it's not supposed to be negative. And this is why. So right here, this one is saying -3 times -3. That's exactly what we want. That's what squared is about. But on this one, this is actually saying 3 times 3, and then multiply by -1. Order of operations. So make sure when you put it in your calculator that you have that exponent outside the parentheses, okay? All right, where were we? We are on this 4th term here, which is 4 times 2 times -3 cubed. And I get -216, and that's x, okay? Now, last term here, we have 1 times 1 times -3 to the 4th, okay? If you do -3 to the 4th in your calculator, you get +81. And what do you know? That was the same answer, let me show you, as if we did it the long way, okay? So again, you can use either strategy to get your answer. It's just one takes a little bit more time than the other. I mean, imagine doing this one. This one's to the 5th. So that's like times again, that's what, at least 1, 2, 3, maybe 4 box methods. A lot. So let's see if we can use Pascal's triangle again to help us be able to solve for this. So we want to find where n equals 5, because n equals 5 here. So let's get that row. So it's 1, 5, 10, 10, 5, and 1. Okay. Our A term in this case is 3x, and our B term is -2y. So be careful now too, because we have an extra variable in there, right? Okay, so first one, we have to have our A term, which is 3x, and we're doing it to the highest exponent, which in this case is 5. And then we have our B term, and that's going to start out, remember, at 0. Okay? Remember, those exponents should add to the original. A term, in this case to the 4th. B term, this one's going to be to the 1st, right? I always expand it like this before simplifying so I don't mess up my numbers, okay? So it's really good to make sure that you are doing these in order, step by step. Don't make mistakes. Lots of times when we skip steps, we tend to make mistakes. Okay, again, here we're at our A term. We're going to go down one, which is 2 in this case, and our B term is going to go up 1. And I see I'm still on the right track because that's 5, that's 5. Okay, A term in the first, B term to the 4th, and then we have A term to the 0, and B term to the 5th. Awesome. Okay. So whichever way you want to do it for the ones, you can. I'm just circling them right now. You can cross them off maybe. Okay. So now here's the idea. We have 1 times 3 to the 5th times 1. When you do that in your calculator, you should get 243. Now, be careful here. So this is x to the 5th. And we have y to the 0. But what is y to the 0? It's 1. So I don't have to have any y's in that first term. Now, again, I'm not going to put that addition sign because I have a negative I have to play with, right? So in my calculator right now, and I'm not going to show you on my calculator this time. Okay, I did it earlier. We'll go 5 times 3 to the 4th times negative 2 to the 1st, and we should get a negative 810. You can try that out. Now, if I look at my variables, I have x to the 4th and y to the 1st. Do I have to put the 1 there? I don't, but if you want to, totally okay. All right, next one. 10 times 3 cubed times negative 2 squared. You get 1,080. Right now we have x cubed, y squared. And again, look, 5, that would be 5, that would be 5. Okay? Next one, 10 times 3 squared times negative 3 cubed is a negative 720 x squared y cubed. Again, I'm not doing this math in my head, guys. I did it ahead of time. I'm just trying not to have too much time on the video. We have 5 times 3 to the 1st times negative 2 to the 4th. That gives us a positive 80 x to the 1st, y to the 4th. And then our last term, we have 1 times negative 2y, and all of that's to the 5th. We get negative 32y to the 5th. I don't know about you, but that was way better than doing box, box, box. I think I would have ran out of room. All right, try and practice a little bit.